In part A of the lab, we're going to use a 50 milliliter graduated cylinder to measure 20 milliliters of treated milk. Then we're going to place this 20 milliliters of milk into a 50 milliliter beaker, which you can see off to the left. Next, we're going to place the beaker of treated milk on a hot plate, and we're going to heat this very carefully and slowly. We need it to reach 37 degrees Celsius, and then we'll discontinue the heating. So I do have a thermometer set up with a thermometer clamp next to a ring stand so that we can track the temperature of the milk. Once the temperature has reached 37 degrees Celsius, we're going to turn off the heat, and then we're going to add 8 drops of a rennet suspension to the milk. Then we'll stir it really well, and we'll let it sit for 15 minutes. While we're waiting for the milk solution to react with the rennet solution, we're going to get 3 strips of cheesecloth. So it looks like we already have one there. So I'm just going to cut another piece, and this will be used to filter out any liquid from the curds that form. Next, we're going to weigh an empty beaker so that we can eventually place our curds into this beaker and get a final mass for the curds. Now, unfortunately, the footage for the next part was lost, so you'll just have to trust me that I separated the liquid from the curds using the cheesecloth. But you can find the final mass on Canvas. In part B of the lab, we're going to add 3 milliliters of litmus milk to 2 10-centimeter test tubes. So here I'm using a disposable pipette, and we're just going to use the markings to measure out 1 milliliter of litmus milk at a time. So we'll add 3 milliliters total to each test tube. So now we have completed the first part of part B. Next, we're going to add 20 drops of 5% pancreatin suspension to one tube, so that will be the tube on the left, and then we're going to add 20 drops of distilled water to the other tube. Then we'll mix the 2 tubes either by inversion or agitation, and the 2 tubes should still be that kind of purplish blue color at the end. Next, we're going to place both tubes into a warm water bath that is maintained at 30 to 40 degrees Celsius. So I do have a thermometer in the water bath to ensure that it's at the correct temperature. I've also labeled both of my test tubes so I can keep track of which one is which. Now we're going to allow the tubes to remain in the bath for at least 45 minutes. Then we'll mix the contents and observe their color. After 45 minutes, we removed the tubes from the hot plate, and now we can mix them and observe their different colors. So let's look at the first tube where we mixed our litmus milk with 20 drops of water. The color didn't change very much here. It still stayed that sort of purplish or bluish color. So now let's compare that to the tube where we mix litmus milk with the 5% pancreatin suspension. So this color is more of a pink color. And here are the tubes side by side so you can see the differences in their colors. Make sure to write down your observations. In part C of the lab, you'll notice that I've labeled 4 different test tubes. The first one is labeled water, and I've already added 1 milliliter of water to that test tube. The second one is labeled pepsin, and I'm about to add 1 milliliter of a 1% pepsin solution to the second test tube. The third test tube is labeled trypsin, and I'll add a 1% solution of trypsin to that test tube. And the last test tube is labeled meat tenderizer, and I'll add a solution of meat tenderizer to that test tube. So now that each test tube contains 1 milliliter of the appropriate solution, we're going to add gelatin, double strength. However, the lab was a little bit cold this day, and you can see the gelatin isn't moving, so I'm going to have to warm it up so that I can actually add it to the test tubes. So after placing the gelatin in a warm water bath for a few minutes, it liquefied, so now I can add it to our test tubes. So I'm just using a disposable pipette to add 1 milliliter of the gelatin solution to each of the test tubes that you can see on the screen. So now that each test tube contains 1 milliliter of gelatin, we're going to mix each test tube and let them sit for 10 minutes, and then we'll add them to an ice bath. Now we'll place each of the 4 test tubes into our ice bath, and we're going to wait until the first test tube, water, turns into a gel-like substance. That will be our control, and then we can look at the other test tubes and make observations. After a few minutes, the water in test tube 1 has turned into a gel-like substance. So when I tilt the test tube, the water doesn't move. It has become solid. So now let's check the other test tubes. So the pepsin test tube has also formed a gel-like substance that doesn't really move when the test tube is tilted. So now let's see what happened in test tube 3. In test tube 3, the solution is still a liquid, so this did not turn into a gel-like substance. And let's check the last test tube 4. This solution also turned into a gel-like substance, so it's not tilting when I tilt the test tube. So make sure to write down your observations. In part D of the lab, we're going to start by adding 2 milliliters of a 5% sucrose solution to the test tube on the right. Then we're going to add 2 milliliters of distilled water as a control in the other test tube on the left. In the next step of part D, we're going to add 2 milliliters of yeast suspension to each test tube. And notice that I swirled the suspension a little just to mix it. Now, once we've added 2 milliliters of yeast suspension to each test tube, we're then going to heat the test tubes for 15 minutes. Now we're going to add our test tubes to a warm water bath that is between 38 to 40 degrees Celsius. And we'll let them sit for 15 minutes. After 15 minutes, I removed the test tubes from the warm water bath, and let's just take a look at the different test tubes. So this is our test tube with water, and notice that not a lot has happened. It looks pretty similar. But now let's look at our other test tube that contained the 5% sucrose solution. We can see that there's some bubbles at the top. Next, we're going to test each of our solutions using Benedict's reagent. So first, I grabbed 2 clean test tubes, and we're going to add 2 milliliters of Benedict's reagent to each of those clean test tubes. And remember, Benedict's reagent is blue due to copper ions that are present in the solution. Additionally, Benedict's reagent is an oxidizing reagent. So once we've added the appropriate amount of Benedict's reagent to each of the clean test tubes, we're then going to add 8 drops of each of our previous solutions to those test tubes. So we'll add 8 drops of our yeast suspension mixed with water to one test tube, and 8 drops of our sucrose solution mixed with yeast to the other test tube. So once I've finished adding the appropriate amounts of each solution, I'm going to mix those test tubes, and then we'll place them in a warm water bath for 3 minutes. So here is our hot water bath, and I'm placing our test tubes in the hot water bath to rest for 3 minutes. Also, I made sure to label the test tubes so I could keep track of which solution was in which test tube. So after 3 minutes, we're going to observe any color changes that occur. I'll fast forward the video so you can see the color changes occurring in real time. After 3 minutes, we'll remove the test tubes and make our observations. So let's look at our first test tube, which contained yeast and sucrose. And then we reacted it with Benedict's reagent. So here we can definitely see a color change. It's sort of an orange reddish color, and there is precipitate at the bottom. If we compare that to our control, which had water and yeast as well as Benedict's reagent, nothing happened. It stayed the same color. You can now complete the lab assignment on Canvas.